This is the second part of 3.2. So the video starts off, or it ended, the first part of the video ended at this problem. And so just, if you have not watched the first part of the video, go back and watch the first part of the video. I did want to make another comment about this one problem. Notice, because it's fourth degree, that if you go back to the last, the video, the last slide I covered, it has, at most it would have 4 zeros. At most it would have 4 zeros. And it has n-1, or 3 turning points, at most. And so notice it does have 3 turning points, because it went down, then up, then down, then back up. So it has 3 turning points. It actually has 4 zeros, but really 3 distinct zeros, because 5 is being repeated. So another fact, I mentioned this in the previous graph. There's if you ever have repeated zeros, so once you have it in factored form, x minus a to a certain power, it's repeated zeros. So it's possible for me to have x minus 2 to the 3rd power. So when I set this equal to 0, it's x equals 2, but it happens 3 times. So literally x minus 2, x minus 2, x minus 2. Now when you look at the graph, you're only going to see one of them. Okay, so x equals 2 is the 0, but it happens 3 times. All right, because it's possible for me to, I could take a polynomial and take x plus 2, and multiply them together, and it's going to get a quadratic. Like this. But it only has 1 0, because when you set this equal to 0, you get -2 as the 0. So literally, it would look like this. So it only hits the 0 one time, because it repeats. So it repeats itself. So if k is even, just like what I just did, then the graph bounces. So literally, it comes down to the 0 and it bounces back up. And just like on the previous example, notice it bounced right here. So I know it happens an even amount of times. Okay, whether 2 times or 4 times or 6 times, it happens an even amount of times. And so if k is odd, much like this one, then it crosses through that. So notice on the previous problem, notice this happened just once. This happened just once. This happened just once. Well, this one happened twice because I have it repeated. But the x minus 2 and the x plus 2 just crossed one time. So it only happened one time. So at -2, it went through the 0. At +2, it went through the 0. Graph went through it. And again, if it's an even amount, then it bounces. So let's graph this really quick. And again, I'm not looking for accuracy right now. I really want you to know a couple things on this. I want you to be able to graph this literally within about 10 seconds, 15 seconds at most, be able to graph this problem. So first of all, if you set this equal to 0, you can see the zeros are x equals 3, x equals -1, and x equals -3. So I know I'm going to come over here immediately and put -1, -3, and +3. Those are my zeros. I also want you to notice what type of what degree is this polynomial. Notice this is to the 2nd degree, that's to the 3rd degree, that's to the 2nd degree. That means if I FOILed all that out, you don't have to FOIL it, but if I FOIL that out, that would actually end up being an x to the 7th degree. So notice all of the exponents together, like literally this is, if I multiply this out, x minus 3 2 times, x plus 1 3 times, and x plus 3 2 times. Now, we don't have to multiply all that out, but if we did, the leading term would be positive x to the 7th. That's important because of the end behaviors. So the end behavior, positive x to the 7th, an odd exponent, That means the end behavior will go up over here on the right-hand side, and it will go down on the left-hand side. So that's something that you need to pay attention to. Also, if you notice at 3, so we're talking about this 0 right there. At 3, it's an even exponent, which means it bounces. So that means it does not go through it. Okay, it does not do that. So it literally bounces at x equals 3. So I know it goes back up. At this one right here, at -1, notice it's an odd exponent, so it goes through it. So this literally goes through at -1. And then notice at -3, it's an even exponent, so it bounces. So this literally bounces right here. So the graph is going to look like that. Now, if I wanted accuracy, then what you would need to do is do a little bit of XY chart. And what we're going to concentrate on is basically plugging in some numbers. Specifically, if I plugged in numbers in between there, like for instance, 0. If I plug 0 in, 0 is very easy to calculate. So if I put 0 right here, I'm going to get -3. Put 0 right here, I'm going to get 1. Put 0 right here, I'm going to get 3. And if I multiply all that together, that's -9. So literally, 0. All right, a simple mistake I made, that I still have the exponents here. So this is going to be 9, and that's going to be 1, and that's going to be 9. So I'm going to get 81. So I knew I made a mistake because I know the graph has got to go upward here. So this literally goes all the way up to 81, and then it comes back down. And again, if I wanted to graph for accuracy, I could plug a number in between there. But if I wanted to graph for accuracy, right now I'm not emphasizing that. I really want you to learn in behavior and the way the graph is going to look in a general format. So here's another problem right here. And again, I want you to graph it within a few seconds. And I'm not looking for accuracy necessarily, but I do want you to be accurate on the zeros. So here, I notice this is x equals -2. And I notice this is +3. I also want you to notice that's an odd exponent. That's an odd exponent. So both times it's going to go through. And that means it's also a 4th degree, because 1 and 3, that means it's a 4th degree. Well, 4th degree means, and it's positive, so it's going to go, both the end behaviors, the left hand and the right hand behavior is going to go up. So, and then again, because it's negative, at -2, it's going to go through. So this is going to go down, and then at 3, it's going to go all through as well, because they're both odd exponents. They're both odd exponents. That means they're going to go through the 0. They're going to go through the 0. So now this is what it looks like in general. So again, if I wanted to be a little bit more specific on this, because if a 4th degree means it could have 4 zeros, it could have 4 zeros. And remember, this is actually being repeated 3 times. This right here is being repeated 3 times. And this one's being repeated 1 time. And also, it has in -1 or 3 turning points. At most 3 turning points. So it really could, something in between here like this. Okay, it could. But in general, I'm not looking for that. I'm looking for the end behavior. I'm looking for, do you know that it goes through? Do you know it needs to go through? And if I was looking for a more accurate graph, then you could plug in like 0. Anything in between here, 0, plug in 0, plug in 1, plug in 1, plug in 2, anything in between there. And then you could also plug in numbers over here, like plug in 5, plug in -5. I mean, to get a more accurate graph if we wanted that. All right, so notice here, I'm going to ask you to graph it, and you're like, well, wait a minute, this one's not factored form. Remember, factored form will tell us the zeros. So in this case, what we want to do is factor this. So we're going to factor out a GCF, which is x cubed. And then if we find the zeros, that means this is a 0, x equals 0, and then we're going to set that equal to 0, and we're going to get 4/3 as the other 0. X equals 0, and then 4/3 is the other 0. If we set them both equal to 0. All right, also notice that it's a 4th degree. Here is going to go up and up. And then in between, if you notice, this happens 3 times, so it's an odd exponent, so it goes through. This is also an odd exponent, so it goes through. And again, it could, in between those, it could do, something like this. It could do something like that. But in general, at the 0 mark, it's going to go through it, and it's going to go through it. So in general, I want to know what the graph is going to look like in general. And again, the left-hand behavior goes up, the right-hand behavior goes up. As x gets bigger, then the y gets bigger. As x goes towards negative infinity, the y goes towards positive infinity. Then our last problem, if I had a problem like this, again, get it in factored form. So factor out the GCF. Factor this further. Set it equal to 0, which means that is 0, that is 6, and that is -5. So at 0, at 6, at -5. Notice this is a positive x to the 4th again. So these happen a lot. So the end behaviors will look like that. And notice, notice the multiplicity. So this happens twice. So at 0, it's going to bounce. It's going to bounce at that. These other ones only happen once, so it's literally going to go through. So it goes through this 0, it goes through this 0, but it's going to bounce at this one. So it's not going to go through at the 0 mark. And again, let me keep saying this, if I had asked you to graph it accurately, then you start plugging in numbers like in between here, like plug in -3, -2. Plug in numbers in between here, plug in like 1 and 2, and plug those numbers in to see how low. It's possible this graph goes way down here, and it's possible this only goes here. So you need to, if I wanted a more accurate graph, then you can plug in more numbers to be more accurate. But again, generally, I keep saying this, generally I'm looking for the overall picture of the graph and the zeros and the end behavior. That's the second part of the video 3.2. Make sure you watch both parts of it because this is a big detailed lesson dealing with graphing polynomials of higher degree.